So next question is, a water treatment plant treats 6000 meter cube of water per day. That means they are giving the discharge. Q is equal to 6000 meter cube per day. Alright. As the part of treatment process, discrete particles are required to be settled in a clarifier. A column test indicates that an overflow rate of 1.5 meter per hour. Overflow rate means they are talking about surface overflow rate, that is also denoted by V naught, and that is 1.5 meter per hour. This is in meter per hour. Let's change this discharge as well in meter per hour. Meter cube per day. In a day there are 24 hours, so it changes into meter per hour. So 6000 upon 24 becomes 250. So the discharge comes out to be 250 meter cube per hour. In 1 hour we are putting 250 meter cube discharge of water for in a treatment plant. Surface overflow rate is also given. Now what they are asking is, would produce the desired removal of particle through settling in the clarifier having depth of 3 meter. Volume of the required clarifier. Okay, so they are saying that depth is 3 meter. Alright, they want to know what is the volume. And to know volume, we should know L into B into D. D we know, we want to know L into B. Alright, the discharge, I can say this surface overflow rate is nothing but discharge upon surface area. So this surface area will become equal to Q upon surface overflow rate. And the surface area is nothing but B into L, and discharge is 250, and surface overflow rate is 1.5. So the B into L comes out to be 166.67 meter square. Alright, so the volume becomes B into L into D. Depth is 3. So if we multiply it by 3, we get volume as 500 meter cube. So the answer of this question is 500 meter cube. Let's move on to next question, which is question number 29. Now they are saying that chlorine is used as a disinfectant in a municipal water treatment plant. It achieves 50% of disinfection efficiency. So the 50% of disinfection efficiency is achieved. That means the remaining it is achieved, they have said that the indicator it is achieved in 3 minutes. So 50% efficiency achieved in 3 minutes. So if there are 50% means if there are 100 microorganisms, 50 are remaining. 50 remaining and 50 are removed in 3 minutes. Minimum time required to achieve 99% disinfection. 99% disinfection means 1% remaining, right? So 50% disinfection means 50% remaining, and 1% means 99% means 1% of the disinfection, the microorganism that is remaining, which is still alive, which is still has to be disinfected. So for doing 1% disinfection, how much time we require? So we know by Chick's formula, NT upon N naught is equal to e to the power minus k into t. This NT is the amount of microorganisms remaining. So for 50%, so it will be 50 upon 100, that is e to the power minus k into 3 minutes. So 0.5 e to the power minus k into 3, and if we take log, in on both side, and it is E, so we will do natural log ln 0.5 is equal to minus k into 3, and ln 0.5, and from this we get the value of k as 0.23 minute inverse. This is the value of k. Once we got the value of k, we want to know what is the time to remain 99 to get 99% disinfection. That means 1% is remaining, so 1 by 100 is equal to e to the power minus 0.23 into t. So 0.01, if we take natural log, minus 2.23 into t, and when we calculate this, we get the value of t as 19.93 minutes. So within I can say 20 minutes, 99% of the disinfection will be achieved. So the option is option D. Next is a rapid sand filter comprising a number of filter beds required to produce 99 mld of potable water. Okay, so we are talking about sand filters here, rapid sand filter, and it is saying that 99% of potable water it will require, and consider water loss during backwashing as 5% rate of filtration, as 6 meter per hour, and length to width ratio of filter bed as 1.35. Width of each filter bed is to be kept equal to 5.2 meter. One additional filter bed is to be provided to take care of breakdown, repair and maintenance. Total number of filter beds they just want to know. Okay, so see, how can we know the total number of filter beds? If I know the total discharge is, that means total water requirement, so total water that is going to be filtered is 99 million liters per day, right? And 5% of this potable water as well. So 99 mld plus 5% of 99 into 100, so it gives us 104.05. So the water requirement that comes out to be 104.05 mld. This much water is going to be used. And now they are saying that rate of filtration is also given. Rate of filtration is nothing but we can use it as velocity, 6 meter per hour. We know discharge now, this much discharge is there, so I can get to know that before going to this we should change it into, because the value is in meter per hour, let us change this mld also in meter per hour. 104.05 million liters, first of all, 10 to the power 6 liter, and 1 liter is 10 to the power minus 3 meter cube per day, and we want to change it into per hour, so that comes out to be 24, and so the discharge comes out to be 4342.1 meter cube per hour. Right? Now this is the discharge in meter cube per hour, and we have the velocity, that is 6 velocity or flow rate, we can say, that is rate of filtration 6 meter per hour. So this I can say that this is nothing but surface overflow rate, we can say overflow rate, flow rate, rate of filtration is nothing but discharge upon surface area. So from here surface area comes out to be discharge 4342.1 divided by 6. So the total surface area of filter comes out to be 723.6468 meter square. This is the total surface area. Another thing they have given that the width of each bed is to be kept equal to 5.2 and the length to width ratio of filter bed is 1.35. So length to width ratio is 1.35 and they say that width should be kept to 5.2. Alright meters, length will become 1.35 into 5.2. So length comes out to be 1.35 into 5.2. Length comes out to be 7.02 meters. Alright. So one filter surface area, if I want to calculate the surface area of one filter, surface area of one filter is equal to length into width, that is 7.02 into 5.2, that comes out to be 36.504 meter square. So I have the total surface area of filter and I have the surface area of one filter. Now I know how can I calculate the number of filters. So the number of filters is equal to 723.68 divided by 36.504. So it comes out 19.82. That is approximately equal to 20. So should I take on 20? No, because they are saying that they have to take that one additional filter bed is to be provided. So these 20 is the number that is needed for filtration of this much water. How much? 99 mld. But I need one more extra for the repair and maintenance work. So total number of filter becomes 21. So the answer is, correct answer will be 21.